The whole reason we do vector calculus, vector fields. Every point has a vector sticking off of it. This is a field. Electric fields, magnetic fields, gravitational fields, airflow, fluid flow, strain in an object, stress in an object. All these are fields. Every point has a force sticking on it. I have a curve. Every point on the curve has a force on it. Looking at the tangent vector, I scale it back to unit length. We'll always use capital T for this. The amount of the force along the curve is that projection of the vector onto the tangent, which is the dot product against the unit vector. This is a number, so this is what we're going to integrate. I have my surface, which is then 2 parameters giving me a grid of curves. So every point is on the intersection of 2 curves, has a vector force sticking out of it. Little n will always stand for the unit outer normal. Outer meaning right-hand rule, or if it's like a skin of an orange, sticking out of the orange. Right-hand rule, your thumb is the normal and your fingers curl around the edge. Take the projection of that vector in the normal direction. That number is the amount of the force leaving the surface. This is called the flux. Let's start integrating. I've got our curve, and I have the amount of the force along the curve I want to compute. So, as always, parameterize. One parameter. Write it in vector form. You just take it and wrap it in angle brackets. Then my ds is the length of the tangent vector, dt. But my unit tangent is r prime over the length. So those are going to cancel. So when I plug in my parameter domain, I plug into the function, I just get r prime dt left over. So this is going to be a new notation we'll be using. F dot dr. It's exactly the same as what we've been doing, it's just a new notation. Dr is the unit tangent ds, computing the flux integral, which is the amount of force that goes across a surface. Parameterize, 2 parameters, call them u and v just for this. Write it in vector form, so I wrap the whole thing in angle brackets. ds is the length of the cross product, du dv. But my normal vector, every point lies on the intersection of these 2 parameter curves. So the 2 tangent vectors that I'm finding my ds for, when I cross those, I get the normal vector. Divide by the length, now it's the unit normal. And the lengths cancel. So when I plug in my parameter domain, plug in all my points, All that's left over is the normal du dv. So this again will be a new notation we'll use. So the d vector s stands for normal vector ds, because the lengths cancel.